So till now we have seen analysis method, how to simplify a complex series connected network and parallel connected network. So today also we'll continue with that point. So mute, all are requested to mute your mic. So let us start with today's session. We'll see the resistive circuit. So meaning of resistive, you all know the meaning of resistive circuit. Electrical circuit where resistances are connected in a specific arrangement. We have seen simple circuit and a complex circuit. In a simple circuit, the resistances may be connected one after other, or they may have a common point. So the some resistances are connected in series, and some electrical circuit where the resistances are connected parallel. We have also seen a combination of two circuits. Means in a given electric circuit, some of the resistances are connected in series and some of the resistances are connected in parallel. So in such type of circuit, we have to, our task is to find out the equivalent resistance. So for that we have already seen the analysis, how to simplify a number of resistances connected in series and number of resistances connected in parallel. So with the help of this technique, we will simplify any given electrical network. So today also we'll continue with that point. So we'll see analysis of a simple circuit, then the voltage divider rule and the current divider rule. So these two rules are very important and this will be helpful for analyzing DC circuit as well as AC circuit. So our first chapter is DC circuit, means direct current, a circuit based on direct current. So in that we have to use a voltage divider rule and the current divider rule. So before using this rule, we must know the voltage division and current division. So we have already seen in case of series circuit, a current remains same and the voltage divides. So for series circuit, for analysis of any voltage or current, we can use voltage divider rule to calculate the circuit current or any unknown parameter, right? So voltage divider formula can be used in a circuit where voltage divides. So we know that in case of given electrical circuit, a voltage divides in a series circuit, right? The current remains same, whereas voltage divides. And we also know that the division of voltage is again depend upon the value of particular resistance. If the value of resistance get changed, the voltage division will get changed. So the voltage drop across particular resistance is depend upon the value of resistance. Why it is independent of current? Because in case of series circuit, the current remains same. So we can use voltage divider rule in case of analysis of series resistive network or series circuit. Similarly, the second rule is the current divider rule. So we can use current divider rule in a circuit where current divides. We have already seen in case of series circuit, the current remains same and voltage divides. That's why we can use voltage divider in case of series circuit. So in case of parallel circuit, there are a number of branches. So to have multiple path for current flow, it means in case of parallel circuit, the current splits. So if a particular branch current if we are interested to calculate a branch current, at that time we have to use a current divider rule. So the current divider rule is applicable for parallel network and the voltage divider rule will be applicable for series connected circuit. Yeah. So we have already seen a series parallel resistor combination and how to simplify this technique, how to simplify the network using a simple series and parallel reduction rule. After that, we'll see a special type of connection, that is Y connection and a delta connection. So some of the resistance may be connected in star, some of the resistance may be connected in delta fashion. We'll see this point afterwards. So these are the very simple formulas to calculate the total resistance of series circuit, that is Rs will be equal to simply the summation of individual resistances. And in case of parallel circuit, a reciprocal of total resistance, that is 1 upon Rp, is the reciprocal of total resistance, will be equal to the summation of reciprocal of individual resistances. So these two formulas, the first formula is applicable for calculation of equivalent resistance of series circuit, and the second formula is applicable for the calculation of equivalent resistance of parallel circuit. So we'll see the complex problem with the help of these two rules, also by using Ohm's law. So let us start with the first problem. So here our task is to calculate the equivalent resistance between A and B. So this is a somewhat complex circuit where they ask you to calculate the equivalent resistance between terminal A and B. Once they assign the main terminals are A and B, we can't change the orientation of terminal A and B, right? So we'll start with the opposite side, where you can see that in this branch, a 1 kilo ohm resistance, 1 kilo ohm resistance will be equivalent to 1000 ohm resistance. K indicate 10 raised to 3 kilo. So you can see 1 kilo ohm resistance and 2 kilo ohm resistance, they are in series. So if the resistances are in series, their total resistance is simply the addition. So by adding these two resistance, you will get a total resistance for this branch will be 3 kilo ohm, right? That's why we'll get 3K. So this will be your step number 1. First of all, we'll add these two resistances. After that, you can see that this 3 kilo ohm resistance and 6 kilo ohm resistance will come in parallel, right? Because we can see that both the terminal 3 kilo ohm and 6 kilo ohm, both the terminals are connected to a common point. So we can say that this combined resistance is of 3 kilo ohm and this 6 kilo ohm, they are connected in parallel. So we know that if the resistances are connected in parallel and there are only two resistances in parallel, then how to calculate the total resistance? We can simply calculate the total resistance by multiplying the two resistances, and again we'll divide that with the addition of the two resistances. So simply we can say its equivalent resistance will be 6 into 3, that is 18, divided by 6 plus 3, that is 9. 18 divided by 9 will gives us 2 kilo ohm resistance. So we can see the 6 kilo ohm resistance and 3 kilo ohm resistance will come in parallel, and there after calculation its value will become 2 kilo ohm, right? So after that, a 2 kilo ohm resistance will come in series with 10 kilo ohm resistance. So 10 plus 2 will give us the 12 kilo ohm resistance, right? So this 10 kilo ohm resistance plus a calculated resistance of 2 kilo ohm resistance will come in series, and then by adding these two resistances we will get a new circuit. You can see a simplified diagram for above circuit. So this is the 12k ohm resistance. So the next step will be we have to solve the parallel combination of 12 kilo ohm resistance and 6 kilo ohm resistance. So the total resistance will be what? 12 into 16 divided by 12 plus 6. Right. So we'll solve this parallel combination. So after solving a parallel combination of 6k and 12k ohm resistance, their answer will be 4 kilo ohm resistance. So after that, this 4 kilo ohm resistance will come in series with 2 kilo ohm resistance, right? So the 4 plus 2 will give us 6 kilo ohm resistance. You can see in next figure, this is the simplified diagram. So you will get a 6 kilo ohm resistance. You will get this from 2 kilo ohm resistance plus 6 kilo ohm resistance in parallel with 12 kilo ohm resistance. So these are the simplified steps. So after that, you can see the 6 kilo ohm resistance and 6 kilo ohm resistance, they are in parallel. So we have to solve these two resistances. 6 into 6 divided by 6 plus 6. It will give us 3 ohm, right? So it will give us 3 ohm. Now 3 ohm and 9 ohm will come in series and it will become 12. Again, this 12 ohm will come in parallel with 4 kilo ohm. 12 kilo ohm in parallel with 4 kilo ohm. So after calculation, it will becomes 3 kilo ohm, and then by adding 3 kilo ohm and 2 kilo ohm, your resultant answer will be 5 kilo ohm will be the total resistance. Is it clear to all of you? So from your side, how to solve this problem? Here again we have to calculate the equivalent resistance between terminal A and B. So first step is to observe the picture or observe the circuit diagram and identify which elements are connected in series and which elements are connected in parallel. So let us see how to solve this problem. So by observing the given circuit, we can say this 3 kilo ohm resistance and 6 kilo ohm resistance, they are connected in series. So first we will simplify these two resistances. So 3k plus 6k will give us 9 kilo ohm resistance. So after that, we'll draw a simplified diagram. So so this is the simplified diagram where 6 and 3 ohm resistance will be replaced by 9 kilo ohm resistance. So now in this circuit we can see a 9 kilo ohm resistance and 18 kilo ohm resistance, they are in parallel, and this parallel combination is connected in series with 6 kilo ohm resistance and 10 kilo ohm resistance. So for simplicity, I have written here that the resistors are in series if they carry exactly the same current. So this is very important statement. You have to always remember this. Resistors are in series if they carry exactly the same current. Again, resistors are in parallel if they are connected exactly between the same two common nodes. Right, so here you can see this is a node, and again this is a node. So one of the terminal of 18k ohm resistance and 9k ohm resistance are connected to a common node. Also here you can see the other terminal of 18 kilo ohm resistance and other terminal of 9 kilo ohm resistance is connected to a common node. So such structure or arrangement is called as the parallel combination. So to solve this parallel combination, if there are only two resistances, then just multiply these two resistances and divide the addition of the two resistances. So the total resistance you will get like this: 9 into 18 divided by 9 plus 18. So after calculation, you can calculate on your calculator or a mobile 18k parallel with 9k. Its equivalent calculation will give us the 6 kilo ohm. So these two individual resistances, 18 kilo ohm resistance and 9k ohm resistance, will be replaced by a single resistance of value 6 kilo ohm. So after that, this 6 kilo ohm resistance will come in series with 6 kilo ohm resistance and 10 kilo ohm resistance. So the resultant answer or the total effective resistance between terminal A and B will be 6 plus 6 plus 10. So your final answer will be 22. So this is the next point where we'll see the effect of resistance tolerance. So if you can see any resistance, there is a tolerance. There may be 5% plus minus value, 10% plus minus value, or 20% plus minus value. So here we can see a simple circuit where a 10-volt battery is connected across the resistance of value R ohm. So here the nominal value of resistance is given as 2.7K, and the resistance tolerance is 10%. So we have to do a calculation for two times, for minimum value and maximum value. Minimum value means we have to reduce 10% from 2.7K, and we have to do a calculation. That will be the answers for case 1, and for case 2 we have to add 10% in 2.7 kilo ohm resistance, and we have to do calculations, right? So we'll see the effect. Here you can see a nominal current. According to Ohm's law, circuit current can be calculated using formula V by R. So we'll use the actual value over here. So current I will be equal to V divided by R. So here V is 10 volt and the value of resistance is 2.7 kilo. So it is divided by 2.7. So we'll get the current as 3.704 milliamperes. Why it is milliamperes? Because the value of resistance is 2.7 kilo. So in division, 2.7 into 10 raised to 3 m. So on numerator it will become 10 raised to minus 3. That's why you will get the value of current as 3.704 milliampere. Similarly, we have calculated the nominal power here. So to calculate a power, we use a formula P is equal to V square divided by R. So the value of voltage given as 10 volt. So it is 10 square divided by resistance value, that is 2.7. into 10 raised to 3. It will give us a 37.04 milliwatt will be the power. So after that, we'll calculate the minimum current in a circuit and the maximum current in a circuit on a basis of resistance tolerance. So you can see a minimum current. So minimum current, to have a minimum current, there must be a maximum resistance. So in 2.7 kilo ohm resistance, we'll add a 10% tolerance. So you'll get the minimum circuit current as V by R. So here V is 10 and the R value is 2.7, and where a 10% is added. If we consider the ideal value as a 1, we'll add a 10%, it will become 1.1. So we'll multiply 1.1 with 2.7. It will give us the minimum current. We'll have a maximum resistance. Then in a circuit there will be a minimum current. So the minimum current value is 3.367 milliampere. Similarly, a maximum current for a given circuit, we can calculate using formula V by R. Here the value of R is different. We have to reduce 10% from 2.7. So for that, here 0.9 factor is considered. So Imax will be 10 divided by 0.9 into 2.7. It will give us 4.115 milliamps will be the current. So these are the effects of adding tolerance, resistance tolerance. So depending upon the value of current, we can calculate the maximum and minimum power. Now we'll see the circuit with series parallel resistor combination. The combination of component can reduce the complexity of circuit and render it suitable for analysis using the basic tool developed so far. So these are again important points. Combining resistance in series eliminates one node from a circuit. So this is very important. Just remember this. Combining resistors in series eliminates one node from the circuit. Similarly, combining resistance in parallel eliminates one loop from the circuit. So these are the general strategy. Please mute. All the students are requested to mute your mic, mute your speaker.
आधार कार्डची झेरॉक्स त्या दिवशी दिलंय मी. आधार कार्डची झेरॉक्स घेऊन गेले.
रुची कोण आहे?
ते नाव त्याचं दाखवतात मग मागं मी पहिलं ह्यांचं नाव 4
So these are the general strategies. Reduce the complexity until the circuit become simple enough to analyze. Then we have to use data from simplified circuit to compute the desired variable in an original circuit. Hence, one must keep track of any relationship between the variables. So we'll see a more complicated problem here. Here we wish to find out all the currents and the voltage level in a ladder network shown. So in the circuit, we have to find out the current I1, I2, I3, I4, I5, also the voltages VA, VB and VC. So for any complex circuit, first we have to make a simple circuit by using series parallel reduction rule. So here, first reduce it to a single loop circuit. So here we are having the three loops. Which are they? This is your loop number 1, loop number 2, and loop number 3. So the analysis strategy will be what? First, we have to reduce these three loops to a single loop circuit. So to convert this complex circuit to a simple one, we have to use a series and parallel reduction rule over here. So you can see here that this 9k ohm resistance and 3 kilo ohm resistance, they are in series. So the result will be 12 kilo ohm resistance. So after that, this 12 kilo ohm resistance will come in parallel with 4 kilo ohm resistance. So after the simplification of parallel combination of 4 kilo ohm resistance and 12 kilo ohm resistance, its answer or the simplified diagram will be like this. This part will remain same as it is, and this part is going to change. So after solving 4k parallel with 12 kilo ohm resistance, the result will be 3 kilo ohm resistance. So after that, this 3 kilo ohm resistance and 3 kilo ohm resistance, they are in series. So their reduced value or the equivalent value will be, say, 3 plus 3, it will be 6 kilo ohm. After that, this 6 kilo ohm resistance will come in parallel with 6 kilo ohm resistance, and then by solving 6 parallel with 6, you will get the 3 ohm resistance, and we'll draw a circuit like this. So this is the our strategy was to reduce this complex circuit to a single loop. So this is our first step. So here you can see we are having a simple electrical loop where the two resistances 9k and 3k ohm resistance, they are in series. So we can use Ohm's law over here to calculate the circuit current I1. So according to Ohm's law, current I1 will be what? Voltage divided by resistance. So here voltage is 12 volt and the resistance for the loop is 9 kilo ohm resistance and 3 kilo ohm resistance. So it will give us 12 volt divided by 12. So we'll get 1 milliamps. Similarly, here we'll see how to apply voltage divider rule. So here we have calculated circuit current I using Ohm's law, and we can calculate a particular voltage VA using voltage divider rule. So according to voltage divider rule, the branch voltage will be equal to total voltage or applied voltage, that is 12 volt, multiplied with the resistance 3 ohm divided by addition of all resistances. With the help of this formula, you can calculate the voltage. So for this diagram, this is the original diagram. We have calculated the circuit current I1 and VA. So after that, we can use the simplified diagrams to calculate the remaining voltages using Ohm's law. So this is your actual diagram. So in the given diagram, we know the value of current I1 and voltage VA. So with the help of this, we can calculate the circuit current I2. Here we know the value of resistance 6 kilo ohm resistance and the voltage is known. So current I2 will be what? I2 will be VA divided by 6. Right. So according to Ohm's law, current I2 will be equal to VA, that will be the voltage, divided by the resistance. it will give us the circuit current I2. Similarly, we can calculate current I3. So this is your circuit current I3. So current VB will be what? This is the resistance value 3K, and we have to calculate the current. So VB will be 3 kilo ohm resistance multiplied with current I3. So these are the only steps. With the help of this step, we can calculate any branch current or any voltage across. So here your task is to calculate the voltage V0. So try to find out voltage V0 and current I0. So try to solve it by your own. We'll see the solution in next session. Okay.